March 15th, 1943. Wait 47 hours. Messerschmitt Factory, Augsburg, Bavaria. Hans von Ohain stood in the experimental engine bay, watching his creation destroy itself. The Jumo 004 turbojet screamed at 12,000 RPM. Metal temperature gauges showed 1100 degrees Celsius in the combustion chamber. Far too hot. The turbine blades were glowing red, warping under thermal stress. Any second now, catastrophic failure. The engine exploded at 08:49 hours. Turbine disc fragmented, sent shrapnel through the test cell. Von Ohain dove behind a concrete barrier. Metal fragments hit the walls. The sound was deafening, like 1,000 hammers striking steel simultaneously. Then silence. Just the hiss of escaping gases, the smell of burned metal. He stood up, looked at the wreckage, his 6th prototype, his 6th failure. 6 months of work destroyed in 97 seconds of operation. His assistant, Ernst Heinkel Jr., approached carefully. "That's it then, we're done." "Not done, just learning what doesn't work." "The Luftwaffe won't see it that way." Von Ohain knew he was right. The Luftwaffe High Command had already expressed skepticism. Jet engines were unproven technology, too experimental, too risky, too expensive. Germany was fighting a war on multiple fronts. Resources were scarce. Every Reichsmark counted. Every kilogram of strategic materials mattered. Wasting them on experimental engines that kept exploding was unacceptable. Let's pause here for a moment. If you find value in stories like this, you can support the channel by liking the video and subscribing. After watching, leaving a brief comment, even a simple word, helps more than you might expect. Your support keeps these stories alive and visible. Thank you. Let's move on. The meeting happened 2 days later, March 17th, Luftwaffe High Command, Berlin. Von Ohain presented his progress report. 6 prototypes built, 6 failures. Total cost, 1.3 million Reichsmarks. 0 operational engines produced. General Lieutenant Adolf Galland listened to the report. His face showed no emotion. Fighter ace, veteran of Spain, Poland, France, Battle of Britain. 104 confirmed kills. He understood combat, understood what pilots needed. He didn't understand jet engines. "Herr von Ohain, you've spent over 1 million Reichsmarks. What do we have to show for it?" "We have data. 6 failures teach us 6 ways not to build jet engines. We need engines that work, not lessons in failure. Every engine brought us closer to success. The thermal problems are solvable. We need better alloys, different combustion chamber design, improved cooling." Reichsmarshal Hermann Göring interrupted. "Commander of the Luftwaffe, 2nd most powerful man in Germany after Hitler. How much closer? Another 1 million Reichsmarks? Another 6 months? Another dozen explosions?" "I need 3 more months, maybe 4. "Maybe?" Göring stood up, walked to the window, looked out at Berlin. "We're fighting the entire world. The Americans are building bombers faster than we can shoot them down. The British are bombing our cities every night. The Eastern Front consumes thousands of aircraft. And you want me to gamble resources on maybe?" "This isn't gambling. This is development. Jets will give us overwhelming advantage." "If they work." "They will work." "When?" Von Ohain hesitated. Honesty or optimism? Truth or what they wanted to hear? 6 months for a reliable prototype. 12 months for production models. Göring turned back. His expression was cold. Final. "I'm terminating the program. Effective immediately. Focus all resources on conventional engines. Proven technology. No more experiments." "Herr Reichsmarschall, this is a mistake. Jets are the future." "The future doesn't matter if we lose the present. This program is banned. You will cease all jet engine development. Transfer your team to conventional engine production. That's an order." Von Ohain stood. "I formally protest this decision." "Your protest is noted and rejected. You're dismissed." The meeting ended. Von Ohain walked out. His program was dead, officially terminated, banned by direct order of Luftwaffe High Command. Everything he had worked for, everything he had proved was possible, killed by bureaucratic decree. But he didn't stop working. March 18th. Von Ohain returned to Augsburg, called a meeting with his core team. 8 engineers, 3 machinists, 2 metallurgists, 13 people total. He explained the situation. High Command has banned jet development. Officially, we no longer exist. Ernst Heinkel spoke first. So we're done? No, we are unofficial. What does that mean? It means we continue working, in secret, without authorization, using budget codes that won't trigger scrutiny. That's theft of military resources. That's saving Germany from its own stupidity. One of the metallurgists, Dr. Friedrich Weber, raised his hand. How do we hide an engine development program? Jets make noise. They create exhaust. They require test facilities. We disguise it as maintenance, engine testing, repair work, conventional engine development. We bury the real work inside legitimate activities. And if we're caught? Von Ohain was quiet for a moment. Everyone knew the answer. Courts-martial, probably execution. Germany didn't tolerate insubordination during wartime, especially not misuse of military resources, especially not disobedience of direct orders from Göring himself. If we're caught, we face consequences. But if we don't do this, Germany loses the war. Allied air superiority will destroy us. Jets are our only chance to regain advantage. So we have a choice. Follow orders and watch Germany burn, or disobey orders and maybe save it. The room was silent. Then Heinkel spoke. I'm in. Weber nodded. I'm in. One by one, all 13 agreed. They would continue. In secret, without authorization, against direct orders, risking everything. The illegal program began immediately. Von Ohain reorganized the workflow. Official work happened during day shift. Conventional engine maintenance, repair, testing, everything visible, everything approved, everything that would pass inspection. The real work happened at night, after 2,200 hours, when supervisors went home, when oversight disappeared. His team would return to the factory, use maintenance as cover, work on jet engines under false budget codes, hide the work inside legitimate operations. They needed parts, turbine blades, combustion chambers, fuel injectors, complex components that couldn't be fabricated without authorization. Von Ohain solved this by miscoding purchase orders. He ordered parts as conventional engine components with slight specification changes. A turbine blade for a Jumo 211 piston engine was listed, but the actual specifications matched his jet turbine needs. The procurement office approved it, never checked the details. He ordered high-temperature alloys, listed them as experimental conventional engine improvements. Approved. He requisitioned machine time, listed it as maintenance equipment testing. Approved. Every resource he needed, he obtained through creative paperwork, buried inside bureaucratic processes that nobody examined carefully. The budget came from maintenance allocations. Every Luftwaffe facility had maintenance budgets, money for keeping existing equipment operational. Von Ohain diverted portions of that budget, small amounts, 5% here, 3% there, spread across multiple budget codes. No single diversion was large enough to trigger audit, but combined, they funded his program. It was fraud. Technically, but necessary fraud. Germany's procurement system was rigid, inflexible, designed to prevent waste, but also prevented innovation. Sometimes you had to break rules to accomplish missions. This was one of those times. The work was exhausting. His team worked normal shifts during the day, conventional engine work, then returned at night, jet development, 4 hours sleep, then repeat, day after day, week after week. They were always tired, always stressed, always one inspection away from discovery. But they made progress. The fundamental challenge was temperature. Jet engines operated at thermal extremes impossible for conventional engines. A BMW 801 radial engine, standard Luftwaffe power plant, operated at combustion temperatures around 700 degrees Celsius, hot but manageable with standard steel alloys. The pistons and cylinders could handle that thermal load. Von Ohain's jet engine operated at 1100 degrees Celsius. Standard steel melted, warped, failed within minutes. They needed special alloys, chromium-nickel steel, heat-resistant compositions, materials that could maintain structural integrity at temperatures where ordinary steel became soft taffy. But these alloys were expensive, strategically valuable, carefully controlled. Von Ohain couldn't order them through normal channels without triggering questions. How did he solve this? Creative specifications. He ordered experimental high-temperature valve steel for improved piston engine performance. Technically accurate. The alloy could be used for valves. The procurement office approved it, never asked why he needed 50 kilograms, never questioned the specific composition. The paperwork looked legitimate. That was enough. He used that alloy to fabricate turbine blades. Each blade was machined from solid stock, hand-finished, balanced to within 0.05 grams, 24 blades per turbine disc. Each blade had to be identical. Any imbalance at 12,000 RPM would destroy the engine through vibration. The machining took 3 days per blade set, 72 days of work for each turbine. This was why conventional procurement couldn't work. Official channels would take 6 months just for approval, then another 6 months for fabrication. His team did it in 10 weeks, working nights, using misappropriated machine time, hiding the work inside routine maintenance operations. April 1943, Prototype 7, new combustion chamber design. Von Ohain had analyzed the previous failures. The problem wasn't just temperature, it was temperature distribution. Hot spots, areas where combustion concentrated. These local temperature spikes exceeded material limits even when average temperature was acceptable. His solution was revolutionary. Annular combustion chamber, ring-shaped, fuel injected at multiple points around the circumference. This distributed combustion evenly, eliminated hot spots, reduced peak temperatures by 150 degrees while maintaining overall efficiency. The mathematics were complex: fuel flow rates, air mixture ratios, injection timing. Everything had to be precisely calculated. Too much fuel, and the engine ran rich. Black smoke, incomplete combustion, wasted energy. Too little fuel and combustion was unstable. Flameouts, engine failure. He spent 3 weeks calculating the optimal parameters, used slide rules, manual calculations, no computers, no digital simulation, just mathematics, physics, engineering intuition developed over years of study. The calculations filled 217 pages of notes, equations, diagrams, cross-references, every variable considered, every interaction analyzed. When he finished, he had a design that should work. Should. Theory was one thing. Reality was different. They tested Prototype 7 at night. The engine started at 23:17 hours on April 23rd. Initial run-up was smooth. No vibration, no unusual sounds. Temperature climbed steadily. 700 degrees, 800, 900. Approaching operating range. 1,000 degrees, still climbing. 1,050, 1,100. Temperature stabilized at 1,090 degrees Celsius, within design parameters. The turbine blades glowed dull red, visible through the exhaust nozzle. But they held. No warping. No failure. The annular combustion chamber was working. Heat distribution was even. Peak temperatures were controlled. The engine ran for 11 minutes. Then a fuel pump failed. Not catastrophic, just mechanical failure of a conventional component. The jet engine itself was fine. They shut down. Examined the turbine. The blades showed minimal wear, some discoloration, some oxide formation, but structurally sound, reusable. 11 minutes, far better than previous attempts. Progress. They replaced the fuel pump, reinforced it, added redundant seals, tested again 2 nights later. This time the engine ran for 37 minutes before they shut it down voluntarily. Not because of failure, because they had proved extended operation was possible. They needed to preserve the engine for further testing. Examine it, learn from it, build the next prototype based on these results. May 1943. Prototype 8. Further improvements. Von Ohain had refined the fuel injection system. 24 injector nozzles instead of 16. Finer fuel atomization. Better mixture control. The combustion was more stable. Temperature variations reduced to plus or minus 15 degrees. Excellent consistency. This prototype ran for 1 hour 43 minutes during its first test. Shutdown was voluntary. Post-test inspection showed minimal wear. The turbine blades could probably run for 25 hours before replacement. That was approaching operational viability. Fighter sorties averaged 1.5 hours. 25 hours meant 16 missions. Acceptable for combat use. But they needed better. Needed certainty. Needed an engine that wouldn't fail in combat. Wouldn't strand pilots in enemy territory. Wouldn't explode during critical maneuvers. Reliability was everything. June 1943. Prototype 9. This was the culmination. Von Ohain incorporated every lesson learned, every failure analyzed, every success replicated. The turbine blades used the best alloy composition. The combustion chamber had optimal geometry. The fuel system had triple redundancy. Every component was over-engineered, heavier than necessary, stronger than required. Because in combat, reliability mattered more than weight. This engine was different. Von Ohain could feel it. Years of engineering experience, intuition. When you worked with machines long enough, you developed a sense. This one was right. Everything about it felt solid, capable, ready. They tested it at night. June 8th. The engine started at 23:17 hours. Smooth ignition, clean run-up. Temperature climbed steadily, stabilized at 1080 degrees. Perfect. The turbine sound was different. Steady. No fluctuation, no hunting. Just smooth, continuous roar. 1 hour passed. 2 hours. 3. The engine ran perfectly. Temperature stable. No vibration. No oil leaks. No warning signs. At 04:20 hours on June 9th, 5 hours after start, they shut it down. Not because of failure, because they had proved the point. The engine worked. It was reliable. It was ready. Von Ohain stood in the test cell, listened to the engine cool, metal clicking as it contracted, the sound of success. The turbine blades had handled 5 hours of continuous operation at 1100 degrees. No warping, no cracking, everything intact. They had done it, built a working jet engine, against orders, in secret, using misappropriated resources. Post-test inspection was meticulous. They disassembled the engine completely, examined every component under magnification, measured every dimension, checked for stress cracks, thermal damage, fatigue, found nothing significant, some wear, normal for 5 hours of operation, but nothing concerning. Nothing that suggested imminent failure. The turbine blades showed oxide coating. Expected. High-temperature oxidation was inevitable, but the oxide layer was thin. Uniform. Protective rather than destructive. The blade profiles remained within tolerance. The balance was maintained. They could run this engine for another 20 hours minimum, maybe 50, maybe more. This was the breakthrough. This was what made everything possible. A jet engine that could survive combat operations. That could be manufactured in quantity. That could power aircraft into battle and bring them home. This was the weapon Germany needed. Now came the hard part. Convincing high command they needed it. July 1943. Von Ohain requested a meeting with Galland, not through official channels, through personal connections. Galland agreed, partly out of curiosity, partly because the war situation had worsened. Allied bombing was devastating German industry. The Luftwaffe was losing air superiority. Any advantage was worth examining. They met at Augsburg. Von Ohain showed him the engine. Running, smooth, powerful. Galland watched for 15 minutes, silent. Then he spoke. "This is what you were ordered to stop developing?" "Yes, Herr General." "How long have you been working on it?" "We never stopped." Galland smiled slightly. "You disobeyed direct orders from Göring." "Yes, sir." "That's execution offense." "I know." "Why?" "Because jets will change everything. Look at this engine. Look what it can do." The engine was producing 840 kilograms of thrust. Weight, 840 kilograms. Thrust-to-weight ratio, 1:1. This meant an aircraft could achieve speeds impossible with conventional engines, 600 miles per hour, maybe 700. Faster than any Allied fighter. Fast enough to intercept bombers before they reached targets. Fast enough to escape Allied fighters. Galland understood immediately. How fast could this make an aircraft? In the Me-262 airframe, 870 kilometers per hour, maybe 900. That's 200 kilometers faster than a P-51 Mustang. Yes, sir. Allied fighters couldn't catch it. Correct. And it could intercept bombers at closing speeds they couldn't defend against. Exactly. Galland walked around the engine, studied it from every angle, fighter pilot mind calculating tactical implications. This wasn't just faster. This was revolutionary. This changed fundamental assumptions about air combat. Does Göring know you continued working? No, sir. Does anyone? Just my team. How many people? 13. 13 people built this, in secret? For 4 months? Yes, sir. Galland was quiet for a long time. Then he made a decision. I'm going to forget this conversation happened. I'm going to forget I saw this engine. You're going to forget I was here. Von Ohain's heart sank. Sir, please. I'm not finished. Tomorrow, I'm going to order an official inspection of your facility. During that inspection, you're going to accidentally show me this engine. I'm going to be shocked, surprised, amazed that someone continued working despite orders. I'm going to recommend immediate reinstatement of the jet program, with full funding, official authorization, everything you need. Why? Because you're right. This will change everything. But I can't support you officially if I know you violated orders. So I need plausible deniability. I need to discover this engine, not have it confessed to me. I understand. Good. One more thing. If this fails, if these engines don't perform as promised, I will personally ensure you're court-martialed. You risked everything on this. Make sure it was worth it. The official inspection happened July 14th. Galland arrived with entourage, inspected conventional engine production, reviewed maintenance operations, everything standard. Then, accidentally, someone opened the wrong door, revealed the test cell, with the jet engine. Running. Galland's performance was perfect. Shock. Amazement. What is that? Von Ohain explained. Carefully. Made it sound like minimal work, small-scale testing. Nothing major, just keeping the research alive in case future needs arose. Galland pretended to be impressed, pretended to see the potential for the first time. This needs immediate attention. I'm reinstating the program, effective immediately, full funding, whatever resources you need. 2 weeks later, official orders arrived. Jet program reinstated, budget approved, 3 million Reichsmarks, authorization to hire additional staff, build production facilities, begin aircraft integration. The Me-262 jet fighter program accelerated. Von Ohein's engines were installed in the airframe. Test flights began. The performance was extraordinary. Maximum speed, 870 kilometers per hour. Climb rate, 1,200 meters per minute. Service ceiling, 11,500 meters. It was faster, could climb higher, and could outrun anything the Allies had. The first test pilot was Fritz Wendel, veteran Messerschmitt test pilot. Over 3,000 hours in experimental aircraft. He had flown prototypes that killed other test pilots, survived crashes that should have been fatal. His assessment would determine whether the Me-262 proceeded to production or died as an interesting failure. His first flight was April 18, 1944. Clear weather, light winds, optimal conditions. He taxied to the runway. The jet engines whined, different sound than piston engines, higher pitched, almost whistling. The throttle response was immediate, smooth, no propeller torque, no engine vibration, just pure thrust. He advanced throttles to full power. The Me-262 accelerated rapidly, faster than any piston aircraft he had flown. 100 kilometers per hour, 150, 200. The nose lifted at 220 kilometers per hour. Rotation. The aircraft left the ground smoothly, climbed at an angle piston fighters couldn't match. At 1,000 meters altitude, he leveled off. Checked instruments. Everything normal. Engine temperatures stable. Fuel flow steady. Control response was precise. The aircraft felt solid, capable. He pushed the throttles forward, full power. The Me-262 accelerated, 400 kilometers per hour, 500, 600. The airspeed indicator climbed rapidly. 700, 800. He reached 840 kilometers per hour at 3,000 meters altitude. No vibration, no flutter, no control problems, just smooth, fast flight. He pulled back into a climb. The Me-262 went vertical, climbed at 1,200 meters per minute, faster than any Allied fighter. At this rate, he could reach 10,000 meters in 8 minutes, intercept bombers before escort fighters could react, attack and escape before defense was possible. He tested combat maneuvers, rolls, turns, dives. The Me-262 was less agile than conventional fighters. Turning radius was larger, roll rate was slower, but the speed compensated. An Allied fighter might turn tighter, but the Me-262 could choose when to engage, could attack from any angle, could escape at will. Speed was control. Speed was survival. His post-flight report was enthusiastic. The Me-262 represents revolutionary advancement in fighter aircraft capability. Speed advantage over Allied fighters is overwhelming. Properly employed, this aircraft could re-establish German air superiority over the Reich. But there were problems. The engines were temperamental. Turbine blades still failed after 25 hours of operation. Not random failure, predictable wear, but it meant engines needed frequent replacement. Logistics nightmare. Combat units would need extensive maintenance support. Spare engines, trained mechanics, complex supply chain. Fuel consumption was enormous. The Jumo 004 burned approximately 1,200 liters per hour at full throttle. A FW-190 burned 350 liters per hour. The jet used 3 times more fuel for comparable flight duration. Germany's fuel supplies were already strained. Strategic bombing had destroyed refineries. Synthetic fuel production was inadequate. Adding fuel-hungry jets to the inventory created additional problems. Pilot training was completely different from conventional aircraft. The Me-262 required gentle handling, smooth throttle inputs. Aggressive maneuvering could cause flameout. Engine failure. If one engine flamed out, the asymmetric thrust made control difficult. Recovery required specific procedures. Pilots had to be retrained completely. This took time, resources, training accidents. One early pilot, Lieutenant Hermann Buchner, described the challenge. Flying the Me-262 is like nothing else. Everything happens faster. You think faster, react faster, make mistakes faster. The aircraft punishes carelessness immediately, but master it, and you become untouchable. No Allied fighter can catch you. You choose every engagement. You dictate terms. That's power. They worked through the problems, improved blade metallurgy, refined fuel systems, developed pilot training programs. By early 1944, the Me-262 was ready for operational deployment, except Hitler interfered. February 1944. Hitler saw the Me-262 demonstration. Messerschmitt test facility. Multiple aircraft flying formation. Demonstrating speed, maneuverability, weapons delivery. Hitler watched from the ground. His response shocked everyone. This aircraft should be a bomber. Galland was present. His reaction was immediate. Mein Führer, it's designed as a fighter, to intercept Allied bombers. That's where we need capability most urgently. Hitler was insistent. I don't care what it's designed as. I want it as a fast bomber. We need to strike back at Allied invasion forces. When they land in France, we need fast bombers to attack the beaches, disrupt the landings. This aircraft can do that. Galland tried to explain the tactical problems. Mein Führer, the bomb load would be minimal, perhaps 500 kilograms maximum. That's not effective for bombing. A conventional bomber carries 3 times that weight. The Me-262's value is fighter interception, bomber escort, air superiority. Hitler became angry. Are you questioning my judgment? No, Mein Führer. I'm explaining the technical limitations. I understand the limitations. I'm ordering you to overcome them. Convert the Me-262 to bomber configuration. Focus production on fighter bombers, not interceptors. This was disaster. Complete disaster. The Me-262's advantage was speed and climb rate. Converting it to bomber meant adding bomb racks, bomb aiming equipment, extra weight, structural reinforcement to handle bomb loads. This added approximately 350 kilograms. Reduced performance significantly. Maximum speed dropped from 870 to 790 kilometers per hour. Climb rate decreased to 800 meters per minute. Service ceiling reduced to 9,000 meters. Every advantage compromised. The aircraft was still faster than Allied piston fighters, but not overwhelmingly faster. P-51 Mustangs could reach 700 kilometers per hour in dives, close enough to engage, close enough to fight. The Me-262's invincibility disappeared. It became just another aircraft, faster than most, but vulnerable. Worse, the bombing capability was minimal. The aircraft could carry 2 250-kilogram SC-250 bombs. Total payload, 500 kilograms. A Ju-88 bomber carried 3,000 kilograms. The Me-262 carried 1/6 that weight. For attacking beach defenses, invasion fleets, fortified positions, 500 kilograms was inadequate. Strategic impact? Minimal. Tactical value? Questionable. But orders were orders. They converted some Me-262s to fighter-bomber configuration, called them Sturmvogel, Stormbirds. Beautiful name. Stupid mission. They could carry the bombs, could reach targets quickly, but couldn't carry enough ordnance to matter, couldn't survive concentrated flak, couldn't evade determined fighter opposition. Meanwhile, Allied bombing intensified. B-17 flying fortress formations struck German industry daily. 1,000 aircraft raids, escorted by P-51 Mustangs, P-47 Thunderbolts. Overwhelming numbers. The Luftwaffe was being bled to death, losing aircraft faster than they could replace them, losing experienced pilots, losing the air war. The Me-262 could have stopped this, should have stopped this. Jets could intercept bombers at speeds too fast for escort fighters to intervene. Could attack from angles the bombers' defensive guns couldn't cover. Could break up formations before they reached targets. Could make daylight bombing too costly to continue. But most Me-262s were configured as bombers, following Hitler's orders, wasting their potential. dying in ground attack missions, shot down by flak, destroyed by Allied fighters during vulnerable attack runs. The kill ratio was terrible. 2 Me-262 losses per mission, exchanging irreplaceable jets for minimal tactical effect. Some units disobeyed, quietly converted their aircraft back to fighter configuration, removed the bomb racks, reinstalled fighter equipment, used them for interception despite orders. These units achieved remarkable success, proved what the Me-262 could do when used properly. Commando Nowotny was the first operational jet fighter unit, commanded by Major Walter Nowotny, ace with 258 kills, veteran of Eastern Front, Spain. He understood air combat, understood tactics, ignored the bomber orders, flew his Me-262s as interceptors, October through November 1944. Commando Nowotny engaged Allied bomber formations repeatedly. Their tactics were revolutionary. High-speed passes, attack from 12 o'clock high, diving through formations at 850 kilometers per hour, firing 30mm Mk, 108 cannons, 4 cannons, 600 rounds per minute combined fire rate, explosive ammunition. Each hit on a B-17 caused catastrophic damage. The closing speeds were extraordinary. Me-262, approaching at 850 kilometers per hour. B-17 flying at 300 kilometers per hour. Combined closing speed, 1,150 kilometers per hour. 320 meters per second. Bomber gunners couldn't track targets moving that fast, couldn't traverse their turrets quickly enough, couldn't aim effectively. They fired wildly, hoping for lucky hits, rarely connecting. The Me-262 pilots fired from 600 meters range, 3-second bursts, then broke away. Zoom climbed to altitude, reset for another pass. The entire attack lasted seconds. Bombers exploded, fell out of formation. Crews had no time to react, no time to defend, no time to understand what hit them. In 3 weeks, Commando Nowotny destroyed 54 Allied aircraft, 27 B-17s, 19 P-51s, 8 P-47s, loss rate, 6 Me-262s, 9-to-1 kill ratio, extraordinary, unprecedented. This proved the concept, proved jets could defeat Allied air superiority, but the unit was too small, 20 aircraft, inadequate fuel supply, limited ammunition. They couldn't be everywhere, couldn't stop every raid, couldn't change the strategic situation, just proved what was possible. What should have been done with more resources, more aircraft, more support. One American pilot, Captain Charles Yeager, encountered an Me-262 during this period. His after-action report described the experience. At 14,000 feet, bogey appeared directly ahead. Closing speed impossible to estimate. Faster than anything I'd seen. I fired. No hits. The bogey passed under my aircraft. I attempted pursuit. Lost visual contact within seconds. Never had a chance. If these aircraft deploy in numbers, bomber escort becomes impossible. But it was too late. Too few aircraft. Too little fuel. Too much damage already done. Allied air forces had established overwhelming numerical superiority. Even with technological advantage, Germany couldn't win. November 1944. Allied intelligence captured a crashed Me-262, transported it to Wright Field, Ohio. American engineers examined it, disassembled the engines, analyzed every component. Their report was remarkable. German jet technology exceeds our current capabilities by approximately 18 months. The Jumo 004 engine represents significant engineering achievement. Construction quality is excellent despite material shortages. Design is sophisticated. If deployed in quantity earlier in the war, this aircraft could have posed severe threat to Allied bombing campaign. The report continued. Detailed analysis of turbine blade metallurgy, combustion chamber design, fuel injection systems, everything. American engineers were impressed, shocked. They had assumed Allied technology led German technology. The Me-262 proved otherwise. Germany had jets, operational jets, flying combat missions. while America was still testing prototypes. The most shocking detail was the development timeline. The Me-262 first flew in 1941, 2 years before American jet prototypes. If Germany had prioritized jet development, if Hitler hadn't demanded bombers, if resources had been allocated properly, the Me-262 could have entered service in 1943, could have established air superiority, changed the entire war. One American engineer wrote in his personal notes, "The Germans had the answer. They built it. Then bureaucracy and political interference destroyed its effectiveness. We're looking at what could have been a war-winning technology wasted by poor decisions at the highest levels." December 1944. Von Ohain was interrogated by Gestapo. Someone had reported the illegal development program, the secret work, the misappropriated resources, the violation of direct orders. They wanted details, names, evidence. They prepared courts-martial. Galland intervened personally, testified that von Ohain's work had been essential, that without his illegal program, jets wouldn't exist, that he had saved German aviation, that punishing him would be insane. The Gestapo didn't care. Rules were rules. Orders were orders. Von Ohain had violated both. He would be tried. Probably executed. Then Hitler was shown the interrogation reports. His response surprised everyone. The man who built jet engines without authorization, while his superiors were too stupid to see their value, promote him. The Gestapo protested. "Mein Führer, he violated direct orders from Reichsmarschall Göring." Then Göring was wrong. This engineer was right. Release him. Give him whatever he needs. Make more engines. Von Ohain was released, promoted to director of jet engine development, given unlimited resources. But it was January 1945. Too late. Germany was collapsing. Allied armies approaching from all directions. Industry destroyed by bombing. Fuel supplies exhausted. The war was over. Jets couldn't save it anymore. May 1945. Germany surrendered. Allied forces captured Messerschmitt facilities, found von Ohain, interrogated him. His story emerged. The banned program, the secret development, the illegal work, the success despite orders. American intelligence was fascinated. They offered him a deal. Come to America. Work on American jet programs. Bring his knowledge, his experience, everything he had learned. In exchange, immunity, citizenship, resources to continue research. He accepted. Von Ohain moved to Wright-Patterson Air Force Base, worked on American jet engine development. His knowledge accelerated American programs by years. The turbines in modern jet engines trace their lineage to his work, his designs, his innovations, everything he developed while working illegally in a Bavarian factory at night. Years later, he was interviewed about the Me-262, about the banned program, about defying orders. The interviewer asked, "Do you regret violating orders?" "I regret that I had to. I regret that the system was too rigid to recognize potential. But do I regret building the engines? Never." "What if you had been caught earlier, before Galland's intervention?" "Then I would have been executed. But the engines would still exist. Someone else would have continued the work. Good ideas don't die because bureaucrats ban them." "Do you think jets could have changed the war outcome?" Von Ohain was quiet for a moment, then answered carefully. If Me-262s had been deployed in 1943 instead of 1944, in fighter configuration instead of bombers, with adequate fuel and pilot training, they could have established temporary air superiority over Germany. Whether that would have changed the ultimate outcome? Probably not. Germany was losing on too many fronts, but it would have made the air war much more costly for the Allies. Many more bombers shot down, many more crews lost. The bombing campaign might have been delayed or reduced. That would have helped German industrial production, extended the war, maybe by months, maybe by a year. So your illegal work could have extended World War II. My illegal work gave Germany its best chance at air defense. What politicians and generals did with that chance, that's a different question. the interviewer pressed. But you knew jets were weapons. You knew they would kill Allied airmen. Does that bother you? War bothers me. The necessity of weapons bothers me. But I'm an engineer. I solve technical problems. The problem was how to build an engine that produces thrust without propellers. I solved it. How that solution was used, that was beyond my control. That sounds like avoiding responsibility. Perhaps. Or perhaps it's recognizing that engineers don't control policy. We create tools. Others decide how to use them. Should I have refused to build jets because they might be used effectively? Should I have obeyed orders to stop, knowing it guaranteed Allied air superiority and more German civilian deaths from bombing? Those are difficult questions. War creates difficult questions. There are no good answers, only choices between bad options and worse options. The interview was published in 1955. It sparked controversy. Some called von Ohain a hero for defying orders. Others called him a war criminal for building weapons. Both views missed the point. He was an engineer who saw a technical solution and pursued it despite bureaucratic opposition. The morality of the result depended on perspective. What's indisputable is this. Von Ohain built the world's first operational jet engines. He did it despite orders to stop, despite lack of authorization, despite criminal penalties for failure. He succeeded through technical brilliance, creative bureaucratic fraud, and absolute determination. The engines he built illegally shot down Allied bombers at rates the Allies called impossible. American crews reported being attacked by aircraft moving at speeds they couldn't track. Guns couldn't traverse fast enough. Formation defenses were useless. Jets appeared, fired, disappeared. Too fast to counter. One B-17 gunner's report from November 1944 describes the experience. At 14:23 hours, unidentified aircraft approached formation from 6 o'clock high. Closing speed estimated 400 miles per hour. I attempted to track with my turret. The bogey passed through formation before I could fire. Never saw anything move that fast. 2 bombers exploded immediately. The bogey was gone before we understood what happened. That was the Me-262. That was von Ohain's banned engine. That was what happened when engineers ignored orders and built what needed to be built. The historical what-ifs are endless. What if Göring had supported jets from the beginning? What if Hitler hadn't demanded bombers? What if Germany had allocated resources properly? What if production had started in 1942 instead of 1944? But those are the wrong questions. The real question is this. What if von Ohain had obeyed orders? What if he had stopped working when commanded? What if he had accepted the ban? Then jets wouldn't exist. Or they would have appeared years later, developed by someone else, probably after the war. The Me-262 would have remained a concept, a might have been, a historical footnote about technology that almost existed. Instead, von Ohain disobeyed, built engines in secret, risked execution, succeeded anyway, created the foundation for all modern jet propulsion, changed aviation forever. Was he right to disobey? That depends on your perspective, on your values, on how you weigh military effectiveness against following orders, on whether you think innovation justifies breaking rules. But one thing is certain, they banned his engine, called it fantasy, unproven, waste of resources, mocked his work as toys. Then those toys shot down Allied bombers at 9-to-1 kill ratios, made American crews afraid to fly, forced Allied tactical changes, proved jets were the future. What he said after the war was simple. They banned the engine that could have saved them. That's not my failure. That's theirs. The Americans who examined his work were shocked, completely shocked. They had dismissed German technology as inferior, backward. They were wrong. Germany had jets, operational jets, flying combat missions, while America was still testing concepts. The Me-262 wasn't just ahead of Allied technology, it was ahead of Allied imagination. Nobody thought jets were possible. Not yet. Not during wartime. Too complex. Too unreliable. Too experimental. Except one engineer proved them wrong. Built engines that worked. That were reliable enough for combat. That were effective enough to change tactics. Did it despite being banned? Despite being mocked? Despite facing execution? Hans von Ohain stood in a test cell in March 1943, watched his sixth engine explode, was ordered to stop working, banned from continuing, mocked as a fantasist. He continued anyway, built engines in secret, proved them in combat, changed history. They banned his engine. It saved the Luftwaffe. For a time. That's not what they expected. That's what shocked them. Sometimes the banned solution is the only solution. Sometimes disobedience is the highest form of service. Sometimes saving the future requires breaking the present. The engine they banned became the engine they needed. Too late to win the war, but early enough to prove the concept, to show what was possible, to create the foundation for everything that came after. Every jet engine flying today traces its lineage to that work, to those illegal nights in Augsburg, to one engineer who refused to accept no for an answer. They banned it. He built it anyway. That's the real lesson. Not about jets, about persistence, about believing in your work when everyone else calls it impossible, about doing what needs to be done even when ordered to stop. What he said remains true. They banned the solution, then wondered why they lost.